All right, guys, we're back for lesson 1-7. We're going to do a brief introduction to how you can solve linear systems with matrices, and we're going to focus on systems with two variables, okay? And this is just a really quick introduction, right? We're going to spend one quick lesson on it. We could spend months on this, but to get you guys some experience with it, and then how to use your graphing calculator to help you solve these, basically so you know what your graphing calculator is doing. So first, remember in the last video that if you have a system of linear equations like this, you can set up your matrix as follows. You take the coefficients 3, 2, and then you take the solution or the constant at 7, and it goes on the other side of this dotted or light line. Here I took -6, 6, and then the answer is also 6, and put that here. Just you have to remember that your x's have to be, your same variables have to be in the same columns, right? So this is my x column, this is my y column, and these are all my constants. So when you're solving a matrix, right, trying to solve a set of linear equations, your goal is to get your matrix in what's called reduced row echelon form. And all that means is that you have ones going down the diagonal and zeros everywhere else. You still have these constants, those don't matter. And why is that important? Because, so for our example, which we would have for a 2 by 2, we'd be looking at this, right? That marker's really bad. This tells us that because there's a 1 there, I can solve that x is going to be equal to whatever this constant a is, and y is going to be equal to whatever this constant b is, right? Because this x must equal a, and this y must equal b. Also works for if you have a 3 by 3, because you'd have x equals a, y equals b, and z would equal c. That's how you pull your solutions out of the matrix. So this is our goal. This is what we're trying to get for our 2 by 2. So I'm going to come over here for this example, and I'm going to write that over here. That our goal is to get a 1, ones down the diagonal, right? That's what we're shooting for. Okay, so if this is my goal, how do I get that? Well, there are 3 different matrix operations you can do. One, you can switch the orders of the rows. So I could take the bottom one and write it on the top, and take the top one and write it on the bottom. That doesn't matter, right? 2, I can multiply or divide an entire row by a non-zero constant. So like if you were solving these equations traditionally, I could see that I can eliminate the x's if I multiplied the whole first equation by 2. You can do the same thing in your matrix, right? The last thing you can do is add or subtract elements from one row from another. So I could say I'm going to take this whole second row and let's say add it to the first one, and then I can replace a row with that. This one's the one that seems a little different, but it's kind of like a puzzle, and you're trying to figure out what one of these things can I do so that I can get ones down the diagonal. So let's start. See, I worked this out before, and now I'm going to work it out with you guys, right? So we want to get this. So one thing that I've noticed, I'm going to do that thing I said where I'm going to multiply this first one by 2 so that maybe I can eliminate the x's. So I'm just going to rewrite my matrix. And I'm going to multiply my first row times 2, and I'm going to get 6, 6, 14, and -6, 6, 6. My bottom row remained unchanged, right? All right, now let's do some combining. Let's combine our 2 rows and replace the first row with it. So if I add row A plus row B, so this is row A, this is row B. Row A plus row B is 0. 6 plus -6. Here, oh, I see I did a multiplication problem, right? An error. 2 times 2, this should be 4. Hopefully you guys caught that, not 6. All right, and now I'm still doing my adding. 4 plus 6 is 10. 14 plus 6 is 20. And my bottom row has not changed. I've just done this third operation to my first row. So I can put a note here. This is row A plus row B. That's how I got that new line. All right, so I've got a 0 here. It's helped me a little bit because I know I could switch those rows and put that 0 on the bottom, and I'd be good because I need a 0 there. But let's keep going. Let's take this last row I'm seeing they all have 6s in it. That's going to be helpful to get some 1s because I can divide this row by 6 and I would end up with 0, 10, 20, that's still the same. Then -1, 1, and 1. All right. Getting closer. Ooh, actually, I'm just going to go ahead and do this while I have to save some space. I'm going to also divide that top row by 10 because 10 divided by 10, that's going to give me a 1 there. And then 20 divided by 10 is going to give me a 2 there. So I'm going to squeeze both of those steps into 1. Now you can see I'm getting really close to my goal. I just have this -1 I need to deal with, and this 1, if I turn it into a 0, I know I can swap the rows and it'll be in the right order. Right? So let's get rid of this -1 first and try to change it to a 1, because really you're looking for 1s on the diagonal. It doesn't matter which diagonal you're going because I can always switch the order of the rows. So I'm looking to get all 1s here right now. So I know I can make that a +1 if I multiply this whole row times -1. So I can do a dot, whatever either, and multiply it by -1. So that leaves me with 0, 1, and 2, and then 1, 1, -1, and -1. Sorry, do my multiplication correctly. That's +1, -1, and -1. Okay, now I have my 1s on my diagonals, which is exactly what I want. Last thing left is to turn this -1 into a 0. So hopefully you're seeing, how can I get this thing to be a 0? Switching up the order of the rows isn't going to help. Multiplying by a number isn't going to help, because if I multiply by -1, then I'm changing that one again, which I want to keep +1. So what about add or subtracting the elements? Hopefully you can see if I add these elements, this is going to turn that to a 0, which is exactly what I want it to be. So I'm going to change this and keep my top row the same. And now to get my bottom row, I'm going to do rows A plus B. A and B. So what do I get when I add them? 0 plus 1 is still 1. Great. 1 plus -1 is 0. And 2 plus -1 is 1. So I have made my goal, zoom it up, sorry, of having it in this reduced row echelon form. And if I want it to be exactly like that, my last step can be to switch the rows. This isn't really necessary though, right? Which I would just write 1, 0, 1 on the top, and then 0, 1, 2 on the bottom. And this tells me that x is equal to 1 and y is equal to 2. Those are my solutions to the equation. And you can check it by doing it algebraically, or let's graph them. I need Desmos actually to graph them. But we can also plug it in and check. Let's do that. So if I plug in 1, 3 times 1 is 3, plus 2 plus 2 is 4, 3 plus 4 is 7. Yep, that works. If I plug in 1 here, -6 times 1 is -6, plus 6 times 2 is 12, and 12 plus -6 is +6. So yes, these work. All right, let's do another example together. Right, here's the new system. It's going to be 3x minus 2y equals 25, and 2x plus 5y equals 4. Okay, and it's already lined up. X's and y's are making columns, so I can go ahead and make my matrix. And like I said, these are dotted lines in your book, but it takes me too long to make these dotted lines every time, so I'm not going to do that. Remember, our goal is to get 1s in the diagonal. This is our goal. Okay, let's see, what can we do? Well, I'm noticing we have these 3s and 2s again, and I'm wondering if we make them both 6s, if we can do some eliminating. So let's do that. So let's take our matrix and rewrite it. Sometimes you try things and they don't work, and it's fine. Just erase them and try something else. Let's try this times -2, and let's try this one times 3, so that we can do something with the first column. So our new matrix is -6, 4 and negative 50. Down here it's 6, 15, and 12. All right, now that I have these here, let's add these two rows to replace one of the other rows. I'm going to replace the top row with a plus b. So I'm going to just go ahead and do it. Negative 6 plus 6 is 0. 4 plus 15 is 19. And negative 50 plus 12 is negative 38. Now I'm going to put a note over here that this is A and this is B. All I did to get this was row A plus row B. And now I'm just going to rewrite my last row. All right, so I'm working backwards again. I'm going to try to make these two 0 and the other diagonals 1 and then switch them. Just because that's the path I started. I tend to do that a lot. So now I'm noticing that these are both factors of 19, right? So I can divide that first row by 19 to get me a 1. I'm going to rewrite. So I'm going to divide this first row by 19 because that's going to give me a 1 there. And then I can see that these are all factors of 3. Well, I multiplied them by 3 up here, right? So it makes sense that I can divide by 3 to get them more simplified. So my new matrix is 0, 1, negative 2, and 2, 5, 4. So we basically took the last row and got it back to its original form, 2, 5, 4. All right, so now my top row looks good. Now I need to just adjust this to get some 1s and some 0s. So what can I do? Well, I can see here that I could make this a negative 5 and eliminate this to get it a 0 here if I have a negative 5 plus a 5. And it won't really impact this because it's already a 0. So let's do that. Let's take this and let's multiply the top one times negative 5. We end up with 0, negative 5, 10, and then my bottom row is still the same. All right, now let's add 5. Let's add these two rows and replace the bottom one because that's the one we need to adjust. So this is going to be, if this is A and B, to get this new row, I'm going to add rows A and rows B. Add row A plus B. So 0 plus 2 is 2. Negative 5 plus 5 is 0. 10 plus 4 is 14. My top row is still this, right? All right, now, hopefully you're seeing how you can get these 1s and 0s, right? If I take my first row, you rewrite, and I divide by negative 5, I'm going to get my 1 that I need there. And I need a 1 here as well. So to get this to be a 1, so I have 1s on my diagonals because my 0s are set up for me, I know I can divide by 2. So then my final matrix would be 0, 1, negative 2, and then 1, 0, 7. All right, and so from this, I can do that last step and switch them around if you want to, but you could also read it from here. Y equals negative 2, x equals 7. But if you want it in the standard setup, you could switch them. So you start with a 1, 0, 1, minus 2, and you get your answer as x equals 7 and y equals negative 2. Which you could go back up here and plug and check in an equation. Okay, 3 times 7 is 21. 21 plus 4 is 25, yes. 2 times 7 is 14, plus 5 times negative 2 is 10. 14 minus 10 is 4. Yes, this works. All right, so that's how you do it by hand. But really, most people don't do that by hand. They use their tools, right? So here's how you're going to use your calculator for this. So let me clear out my matrix because I already did this. Okay, so I'm going to just solve this one here, right? So you need to go to your matrix function. So let me get this off. So you see matrix is here. You hit second matrix. And we'll just put this matrix in for matrix A. You can store all these matrices in here. But let's go to edit and let's edit matrix A. So it needs to be a 3 by 2. 3 by 2. And now we just need to, happened, why is it only? Oh, I have it the wrong way, 2 by 3. So it needs to be 2 by 3. You put your number of rows first. So 2 rows by 3 columns. So now let's just type in our numbers. 3, -2, enter, 25, enter, 2, enter, 5, enter, 4. All right, so there's my matrix. And now, to get it in reduced row echelon form, we're going to get out of this screen. And I'm going to go to second matrix again. And then you're going to go over to math. And you need to go down to number 10, reduced row echelon form, RREF. It's actually not 10, it's B. So then we click that. So what are we finding the reduced row echelon form of? Well, we need to go select our matrix A. So I just go to A, hit enter, close my parentheses, hit enter, and there's my answer, right? Matches what I have down here. 1, 0, 7, 1, 0, 7, 0, 1, -2, and I get the answers from that. So that's what your calculator is able to do all this stuff we did by hand in like that 1 split second to get your answer, right? So that's how you can use the matrix function on your calculator to quickly get an answer to a set of linear equations. Because you could graph this too, right? And find where the points intersect. But that would require rearranging these equations to make sure they're in slope-intercept form so you can actually type them in here, right? So it's about knowing the tools available and which one's the fastest. Because these lines are in standard form, using the matrix function on your calculator is actually the fastest. All right, so I know that was a lot, but hopefully you guys see this like a puzzle and it's just manipulating and trying to figure out, right? Like this isn't the only way you could have solved this. You could have done a bunch of different things or in a different order to get this same matrix down here. Till next time.